Okay. The questions I wanted you to try on your composite volume. Right here, number 3, let's check the top cone first, which was larger. It showed us that it had a diameter all the way across of 12 inches. We know that for the radius then, we're only going to go halfway across, which is going to be 6. So hopefully in your formula you use 6 for your radius. Your height was marked very clearly, and that's 8 inches. So 6 squared times 8 divided by 3 should have given you a volume of 96 pi. The other part of this composite shape is this smaller cone down at the bottom. The smaller cone did give us the radius of 3. It gave us the height of 4. So 3 squared times 4. If we divide that by 3, we're going to get a volume of 12 pi. Since it is a composite shape where these two shapes are pushed together and contain one item, we're going to add together those two separate volumes. So 96 and 12 gives you a total volume of 108 pi. Question number 4 doesn't really end up being a composite shape, so I'm honestly not sure why it's included in this set, but you do get a chance to draw yourself the shape of a cone. We see that the base is 4 meters in diameter, so again, all the way across, if we know that's 4 meters, we know that our radius is only going to be 2, so we need to use 2 in our formula. You are given the height of the shed, which is 3.6, so we will use 3.6 in our formula. And when multiplying your 2 squared times 3.6, we would have to divide by 3, and we get 4.8 pi, which is approximately 15. And the units for this was meters cubed, so we'll fill those in so we have it correct. This first one was inches cubed, so we'll fill that in as well. And again, if you want to show the approximate value where you actually multiplied the 108 times pi, you'd get right around 339. Now, this last question sort of is a composite volume question. It talks about a machine using a funnel to fill soda cans on an assembly line. The funnel has a height of 10 and a diameter of 8. They want to know how many times the machine needs to fill a cone and then fill a can that has the same dimensions. So our cone has got to have a height of 10 and a diameter of 8, and so does our can. So if you look over here, this is a good example or a good way to go ahead and draw the diagram, your funnel or your cone. There's your diameter of 8 and your height of 10. And then we can see that what will happen is they'll send the liquid down into the can through the funnel. And again, you've got the same diameter of 8. You've got your same height of 10. So if you remember, the formula for your cone is going to be pi r squared h divided by 3. So again, if your diameter all the way across the circular base is 8, we're going to need a radius of 4. So 4 squared times your height of 10, and then divided by 3 gives you 53.3 repeating pi. Don't forget the bar over the repeating 3. And when you find your volume for the can or the cylinder, remember it's just pi r squared h. We don't have to divide by 3 for this. So this does give us the full value of 160. If you take 160 and you divide it by 53.3 repeating, you find out that that goes in exactly 3 times. So what this reinforces is the video we watched before our lesson on cones, is you would fill this cone up 3 times to fill up the can or the cylinder that has the exact same dimensions. So again, the cone will need to be filled 3 times to fill each can. Make sure that your note sheets get taped into your notebook. Remember, this lesson on composite volume goes on page 79 and page 80.